Welcome back, I'm Adeesha, and today we're diving deep into Chapter 12, Periodic Trends. Understanding how elements behave is the key to mastering chemistry. It all starts with periodic law. This states that physical and chemical properties recur predictably when elements are arranged by their atomic number. The periodic table is split into three main categories: metals, nonmetals, and metalloids. Each has its own unique set of characteristics. Metals are typically solid, lustrous, and excellent conductors of heat and electricity. They are also ductile and malleable, meaning they can be shaped easily. Nonmetals are the opposite. They're often brittle, dull, and poor conductors. They can exist as solids, liquids, or gases at room temperature. Then we have metalloids. These fascinating elements share properties of both metals and nonmetals, acting as the perfect chemical bridge. Now, let's talk about what drives these properties. Valence electrons. These are the electrons in the outermost shell of an atom. Valence electrons are the ones that decide how an atom will react. They are the social parts of the atom that interact with others. Most elements strive for a full octet. That's 8 electrons in their outer shell, to reach a stable, noble gas-like state. Elements are organized into families or groups that share similar properties. Let's look at the 5 major groups. Group 1 contains the alkali metals. They are soft, highly reactive, and have just one valence electron they're eager to give up. Next are the alkaline earth metals in Group 2. These have 2 valence electrons and are slightly less reactive, but more dense than Group 1. Groups 3 through 12 are the transition metals. These are the hard, lustrous metals we use most often in our daily lives. Group 17 houses the halogens. These are extremely reactive nonmetals that only need one more electron to finish their octet. Finally, Group 18, the noble gases. With a complete outer energy level, they rarely react with anything. They're perfectly stable. Now that we know the groups, let's explore the trends, the general directions that explain how element properties change. First, understand effective nuclear charge. This is the positive pull felt by valence electrons from the protons in the nucleus. But there's also the shielding effect, where inner electrons block some of that pull, allowing outer electrons to stay further away. This brings us to atomic radius, a measure of the atom's size. It's the distance from the nucleus to the outermost electron. As we move across a period from left to right, atomic radius decreases because the increasing nuclear charge pulls electrons tighter. Conversely, moving down a group, the atomic radius increases as more energy levels are added, pushing electrons further out. Ionic radius is similar but measures ions. When metals lose electrons, they shrink, while nonmetals grow larger as they gain them. Next, ionization energy. This is the energy required to remove an electron from an atom. It's essentially how sticky the electrons are. Down a group, ionization energy decreases. Larger atoms hold their outer electrons more loosely, making them easier to remove. But across a period, it increases. Atoms are smaller and the nucleus has a stronger grip on those electrons. Then we have electronegativity, the tendency of an atom to attract electrons when forming a chemical bond. This trend increases toward the top right of the table. Fluorine is the champion here, having the strongest pull for electrons. Finally, let's look at reactivity, how likely an atom is to bond. Metals and nonmetals actually follow opposite trends here. For metals, reactivity increases as you move down a group. The larger the atom, the easier it is to lose that valence electron. For nonmetals, it's the opposite. Reactivity increases as you move up a group, as smaller atoms attract electrons more effectively. To recap, atomic radius decreases across and increases down. Ionization energy and electronegativity do the exact opposite. All of this behavior is governed by the periodic law and the number of protons in each element's nucleus. Time for a quick check. Do you remember what law governs the periodic table? That's right, it's the periodic law. What about ionization energy? Remember, it's the energy needed to remove an electron from a neutral atom. Mastering these trends allows you to predict how any element will behave. It's like having a map for the entire chemical world. I hope this deep dive into Chapter 12 helps you in your chemistry journey. Keep practicing and you'll be an expert in no time. If you found this helpful, please like, follow, and subscribe for more. Thanks for watching Learn with Adeesha. Go out there and start exploring.